So thank you for joining. I'll be talking about the high-level science product program at the Mikulski Archive for Space Telescopes. My name is Dr. Scott Fleming. I work at STScI and I work in the MAST archive. So I have just a few slides to go over. I want to first talk about what high-level science products are. I then wanted to give some motivation as to why you may want to contribute high-level science products to MAST. I'll give you a few resources on the steps involved to contribute high-level science products, and then do a whirlwind tour of just a few of the high-level science products we released in the last year and change. And then I want to leave a lot of time for discussion about not just HLSP questions you might have, but other conversation starters, about accessibility of data products and things like that. So first, let's do a quick overview of what high-level science products are. So HLSPs are data products that the community gives back to us, the archive, that either complement or supplement a MAST-supported mission. What do I mean by complement or supplement? Well, it's intentionally open. We generally want to be as inclusive as possible when it comes to the types of things we accept. So some examples might be products that you derived from a pipeline-produced product of our missions. So that might include your own custom calibration of a light curve from TESS, or your own custom calibrated images or mosaics from Hubble. It could also be derived products from those pipelines. So you might take a Hubble Space Telescope image and run some source extraction on it and send us your list of catalogs of sources that are not default products from the main Hubble pipeline. Other examples could be products from other telescopes. So follow-up observations from space-based telescopes or ground-based telescopes in different wavelength regimes. It don't have to be UV optical IR. It could be X-ray. It could be radio. It could be high energy. And there can be simulations or models that support some of the core science being done by our missions as well. And then the only other major thing to point out is that with extremely rare exceptions, we require at least one accepted peer-reviewed publication that describes the products you're going to give us. And the reason we do that is because we need some way of vetting the quality and algorithms and processes involved. And no one person or even us as a branch can't be experts in every field and every type of data that we accept. And so we rely on the peer review process as one way of sort of doing that sort of vetting process. So why should you contribute high-level science products? I kind of view 4 different pillars when it comes to HLSPs. The first one is reach. So every new high-level science product and every update to an existing high-level science product gets sent around in our monthly newsletter email that goes out to thousands of astronomers in our newsletter mailing list. We also update our MAST social media accounts, our Twitter and our Facebook accounts, the day that we do the update or the release. And given advanced lead time, we also work very hard to time the release of your HLSPs at MAST with other events, including press releases when you have those scheduled, or posting of your paper to the AstroPH mailing list if it's not already up on the archive, or presentations at meetings or conferences. I mean, one example is just today, where we released the first data release from the FANGS HST Galaxy survey that the PI just gave a presentation on today at noon. And those data products are available today at MAST and will be advertised later today or tomorrow in our newsletter as well. Another big pillar is permanence. So the average lifetime of a URL online is only a few years. And MAST is coming up on our 24th anniversary, and we're not going anywhere anytime soon. I promise you that. So we really can provide a long-term, and when I say long-term, I mean multiple generations of PhDs, think of it that way, for your data products to live at. Every high-level science product that gets released at MAST gets a digital object identifier, a DOI. And what these are links that will always point, in the case of HLSPs, to the homepage at MAST. And so even if the name or location of a given HLSP homepage at MAST changes because we have to or because we want to. Our promise to you is that this DOI, and you see two examples from a copy and paste I did from a paper that did this, will always point to that particular URL. And so you can include these DOIs in blue, the numbers and letters there, directly in your papers or other web pages, and guarantee that it will always point to a page that will get people to your data products long-term over time scales of many, many years. Another big one is discoverability. So we have at the archive a search form that's dedicated just to listing and being able to discover all the different high-level science products that we have. We have more than 150 different high-level science products of every size, scope, archival, data science going from dust and solar system all the way up to cosmology. And you can use this search form to browse what's available. We're also adding more and more of the high-level science products to our primary search interfaces, including the MAST portal, which is our browser web-based interface that allows you to search for available data sets for a given coordinate or a given target, so you can discover these high-level science products for certain objects in the sky. Our catalogs are added to our CastJobs interface, which is our web-based SQL server that allows you to do complex SQL queries for some of these large catalogs we get. And we have API access for people who want to programmatically search for these, including astroquery.mast Python package. And the last one is impact. So contributing high-level science products to MAST is a service to our community. In some cases, it satisfies requirements for some funding sources, where some of your funding proposals may expect or even require you to make your data products available to the community, and contributing your products to MAST as an HLSP is a fantastic way to satisfy that requirement. The fact that the high-level science products at the MAST archive get sort of more views than they might in some other situations can also lead to increased citations as more and more users are able to discover and use your products. And also it opens new doors for you to have new collaborations and new opportunities in research as more and more people discover your science, your data products, and what you're experts at. And then the big one that I'm really interested in is accessibility. So we know they're popular. High-level science products as a whole are competitive with our other flagship missions, including Hubble, GALEX, and other things in terms of use. Last year, we distributed something like 35 terabytes worth of high-level science products to users, which is about the total size we have on disk of all the HLSPs combined, which sort of tells us that the demand for these things are basically equivalent to their total size on disk, which means they're pretty popular. And in fact, at certain points in the mission, the K2 high-level science products were actually downloaded by more users and more often than the products that the K2 pipeline made themselves. This is a huge one for me. HLSPs actually lower the barrier to archival science. The fact that they're highly processed data products with good documentation and search tools to allow you to discover them means that if you're an early career scientist or a student, or if you're a member of the public who wants to engage in community science like Zooniverse and similar projects, or if you're a professor who might find yourself as the only astronomer in your entire university, or if the nearest university to you is in a different state or a different country, it can really help. If you're none of those things, but are in fact interested in trying out a creative research idea that combines data that in a field you're not used to, or with a mission you're not used to, or if you had a smaller institution that may not have easy access to really expensive resources like telescope time or high performance computing time, high-level science products really help you and your students be able to engage in novel research, and sort of tries to minimize the learning curves or at least the initial steps needed to get started with that research. An example in one of my own areas of research, many of the K2, the second mission of Kepler, exoplanet papers actually analyzed multiple versions of light curves for the same target as a way to assess detection significance for marginal detections, because you had multiple versions of the same target's light curve from different teams, independent pipelines, independent algorithms, and they use that to be able to assess whether a given signal may or may not be statistically significant. And another fun thing is that there are now multiple examples of high-level science products that at MAST that themselves are based on other high-level science products. And so we already have sort of nested high-level science products as well, which is great to see. Some quick resources. So the homepage is pretty easy. It's just archive.stsci.edu/HLSP. On that page is an orange button that will take you to the page on the right. And at the very bottom of the contribution page, there's a table of content that includes information about the sort of metadata you should make sure your FITS files include if you're going to give us FITS files, file name, rules, and then two different forms. The first one is an interest form, which is optional, but it basically is a way to formally tell us, and more specifically me, that, hey, FYI, I have this set of data I'm interested in contributing, so we can make sure we try to get into our queue. The second form is actually required, which will say when you're really ready to get the ball rolling on the HLSP contribution process, here's some questions we need you to answer. And in particular, the most important thing is filling out the copyright permission to allow us to distribute your products freely to the other astronomers and members of the public. So in general, you want to start the dialogue with MAST as early as possible by either filling out the interest form that's linked on the right or emailing the archive help desk and mention that you have an HLSP you'd like to contribute. So in the last year and change, we've actually released 14 new high-level science products and more than 8 that had 1 or more updates. We typically average an HLSP update or new HLSP every week and a half to 2 weeks throughout the year. So it is actually a pretty continuous flow at the moment, which is great, but it is a small team. There's still only about 3 people working about part-time, each of us, on the whole project. So again, I want to emphasize lead time. Give us as much information as possible, and we really can help you contribute your products to focus around when you want to release them and how you want to release them. Time series light curves in particular had a bumper year, in particular with the test mission that just started. The Diamante, Pathos, CDIPS, and Eleanor, as well as a couple I'll show in a second, were all sort of versions of the TESS light curves that were calibrated, and in some cases offered brand new light curves for targets that didn't get light curves from the mission. Catalogs had a big year, including ultraviolet catalogs. GUVCat is actually right now the de facto unique source catalog for GALAX. PS1 Storm is a catalog of 3 billion with a B sources from pan-stars that had machine learning classification applied to it. And then we also had a decent number of new simulations, which is something we always want to see grow at the archive, including white dwarf calibrators, spectral energy distributions for M dwarfs in the extreme UV to infrared for exoplanet habitability and stellar astrophysics purposes, and even convolutional neural network models from Adina Feinstein, where Stella is sort of providing those models, as well as a notebook to use, Jupyter notebook to use them to help with flare identification and test light curves. And we always have images. There was only one brand new one this year, but there's a lot of ones that give us updates as well throughout the years. And then in November, we had 3 huge releases, including Ulysses had its first data release. Ulysses is a 1,000-orbit HST program to study with UV spectra a number of young, high, and low mass stars. And then QLP, the Quick Look Pipeline, and TESS-SPOC are TESS high-level science products, providing calibrated light curves from the TESS full-frame images. And between QLP and TESS-SPOC by themselves, when we are finished ingesting all of the sectors into our portal and API, there'll be more than 25 million light curves available for you to download and search for all kinds of stellar and exoplanet astrophysics, as well as extragalactic in some cases. Upcoming we're going to be releasing probably this month, calibrated full-frame images that was used by the QLP from sectors 27 through 31 called TICA, which is upcoming very soon. And so even if somehow QLP hasn't provided a target's light curve for you, you would be able to use even these calibrated FFIs to be able to extract your own aperture photometry and do some science with those. So I'm at 15 minutes now. I would love to have questions, conversations about high-level science products at MAST, high-level science products at other archives, ways that we can improve high-level science products, the role high-level science products play in archives. And if there's absolutely crickets, I can try to just go through the home pages of some of the new HLSPs and to sort of gush over them and talk about them one by one. For reference, the HLSP homepage is there, and my contact information is available as well, and the MAST archive help desk.
All right, thank you so much. Like I said in the beginning, if you guys do have questions, you can either unmute yourself and say it out loud, or you can put it in the chat and we can do it through there. Just whatever you're more comfortable with.
Oh, there's a couple of people in the chat, looks like.
We also have a hand raised.
If you want to go ahead, Tess first, and then we'll go in the chat.
All right, thanks. I'm just curious about the process for uploading large data sets.
Sure, yeah. So we've had high-level science products that are tens of terabytes in size. Obviously, it takes some time to download them. But what we do as a service is we state that anything that's on the order of 10, 20 terabytes and less, we don't require additional sort of external funds to support. If you're talking about like petabyte size or things like that, that's where we begin to need to negotiate with you and figure out ways to supplement some of the support for that. And then how do you upload them to MAST? There's a variety of ways. We can set up FTP uploads for truly huge data sets. It doesn't sometimes work, sometimes doesn't. For really large ones, we've also played around with, I'm going to forget the name of it now, Globus Connect for one HLSP was set up, and we use that to download them. We can also pull from you as well. So if you have an ability to give us uploads, we can sort of rsync from you. But it depends on the time scale and what you call big, I guess. Gigabytes are really not a problem. Terabytes is usually okay. And then when you get higher than 10 or so, I start to want to discuss options, if that helps to answer your question.
Yes, thank you.
Sure. There was a question in the chat about guidance on how large a data set should be for a meaningful high-level science product. And that's a really good question. How large has a variety of connotations. So in my opinion, volume or size or number is not a meaningful measure of value, because we have HLSPs that are a single object spectrum. And you might say, well, why would you do that? And the answer is the person combined something like 130 observations with HST and IUE of this one white dwarf calibrator to make a signal-to-noise spectrum of like a few thousand and identify a bazillion lines in it. And so there's a lot of value in HLSPs, whether it's a single target or if it's a huge number. So it really ranges quite a lot. Ultimately, when we decide on what's important to include as a high-level science product, we are very, very open. And I think as long as, to some extent, getting the peer review process answers your question a little bit. You know, if you took 3 spectra of a random set of stars for tests and don't have a particular goal in mind, then, and you can't get it through the peer review process, then it's probably means that maybe it's not really relevant as a high-level science product. But 3 spectra with a specific goal in mind or a purpose in mind are still valuable as high-level science products, if that helps. Yeah, and I can't think of the last time we turned down a high-level science product. I'm sure we'll cross that bridge at some point. Since I've been involved with the program, but we do want to try and be open as open as possible.
Cicero, you can go. You can put it in the chat or you can unmute yourself.
Okay, great. Can you guys hear me?
Yes.
Yes.
Great. Thanks, Scott, for the great talk. I was wondering, can you say a few words on, for example, for the Ulysses catalog, the new data release, how I guess how accessible are cross-matching, or is it possible to do cross-matching spectroscopy data was photometric data, just based on coordinates. And I guess I haven't really checked it out. I'm just curious about your impression on it.
Sure. Yeah, it's a great question. So Ulysses is one of the first spectral-based HLSPs that we've added to the portal, which means that it is accessible in terms of being able to do cone searches for Ulysses products through the portal web browser or through your Python astroquery.mast, which is particularly good if you have a list of, let's say you have a list of 200 stars and you'd like to know which ones might have Ulysses products. You can do that with just a couple lines of Python right now. Or you could upload the list of 100 objects to the MAST portal browser and cross-match that way. Documentation, I will admit, is a little sketchy. So yeah, if it's not obvious, definitely reach out and we can help you. But yeah, that's a great question. And that was one of the driving reasons we wanted to make sure that Ulysses, for example, were added to the portal alongside the regular HST data. Another cool thing, real quick, while I'm on the topic of the portal, is that for Ulysses, we've also linked the HST observations that went into each Ulysses composite spectrum. And so in the portal, you can do a search for Ulysses products and then also ask for the HST regular spectral products that went into a given object spectrum if you want to do your own combining or co-addition, or maybe examine one of the spectra you might think is bad or something. And that information is all available in the basket in the portal.
Great, thank you so much. That's wonderful.
Yeah, and like I said, definitely let us know if you encounter problems, and we can both assist you and also make sure we can get more tutorials to help with that. We're a little behind on documentation, how to do these tricks.
Do we have any more questions?
If not, in the meantime, what I can do maybe is feel free to type in the chat or raise your hand. But I will see if I can drag this up here. So this was our release today of FANGS. FANGS is a large program that's actually combining ALMA data and VLT Muse spectroscopy to study star formation in nearby galaxies. And today they're announcing the first release of the HST mosaics for 29 out of their 38 galaxies. And you can see here there's a table that will allow you to download tar files for the different products, whether you want the sort of the individual images that went into a mosaic or just the mosaics. And in the future, in the next couple of months, we'll be getting the source catalogs from the team as well as a second release. So that was just announced today at AAS. Here's Ulysses. So there's actually a couple of, for Ulysses, we did actually put a little bit of guidance on how to access them in the portal. So we have web pages with some screenshots showing how to select only Ulysses files when you do a search in the browser. So in particular, it would be interesting things for the previous question asker to take a look at and see if they help or not. And then this sort of are some screenshots showing how if you add some Ulysses products into your basket through the browser version, you can also do this through the API as well. You can see the composite, the HST observations that went into a given HLSP from Ulysses, which is a really cool feature we just recently added for Ulysses and will be extending to other HST products in the future. I don't know who in the audience is in what camp of favorite products or missions. you know, I'm a fan of stellar astrophysics and exoplanets, and so having some of these test high-level science products released is going to be a game changer. All of the quick look pipeline products for sectors 1 through 26 are available now to download in bulk, and we are beginning to add them sector by sector into the portal and into our Astro query. There's also support directly in an upcoming, if not already out, version of LightCurve with a K, which is a very popular Python package for interpreting Kepler and TESS light curves. So that's out there. Other highlights. Hazmat's a pretty cool one if you're interested in models of the UV environments of stars, where the team put together some synthetic spectra for a variety of different ages of stars and types of stars. And so that's a really cool one to look into. And then PS1 Storm was one that had a press release because of the size. So there's 2.9 billion objects in the 3Pi Pan-STAR survey, and so the team applied neural networks to figure out whether a given source is a galaxy, a star, a quasar, or some sort of unsure metric. And so if you're doing bulk analyses of Pan-STAR sources, this is a really cool catalog to maybe incorporate into your analyses or compare against. And then GUVCat, I'm a Galax fan, so this is work done by Luciana Bianchi. Galax is infamous for not providing unique source lists. They don't take into account overlap between observations, and so the default pipeline products and default catalogs include multiple sources for the same object in the list. And so the team here has done the work to figure out which Galax sources are in fact the same object and which ones are not, and to figure out the best measurement of them. And they also cross-match their catalog with Gaia and Sloan. So these catalogs are in my opinion, de facto catalogs to use if you want to do any sort of Galax-based catalog science. You're going to want to hit this one first, I think. And it's available both as sort of I think it's CSV files we provide, split by declination, and also it's available in cache jobs for those who are used to using SQL. I can go on and on, but I got about 2 minutes left. So if there's any other questions about high-level science products, otherwise, please always feel free to reach out to MAST in the future.
All right, thank you so much, Scott. If
Sure.
there's no more questions, we'll go ahead and end. Just a reminder that you can continue this conversation at the Slack channel or their exhibit booth. But other than that, that's it.
Yep, you can find me at the STScI booth all week, off and on. All right, thank you all.